Hey everyone, I just wanted to welcome you to this video where we're going to talk about LangChain 0.1.0, and it's the newest version of LangChain. It does represent a lot of changes. If you've used LangChain in the past, they've definitely added a lot, and this video is going to walk you through the basics. So we're going to be walking through this QuickStart. We're going to be walking through how to set up everything. We'll be using a Juniper notebook, show you how to install it. We will also walk through how to create a simple large language model chain, and then we're going to do both a retrieval chain, and then also we're going to wrap it up with a conversational retrieval chain. So stick around if you want to learn more on how this all works. So specifically, we're going to be talking about 0.1.0, which actually is their first stable release of LangChain, and it represents a huge change from what it was there. So it is backward compatible. There's some backward compatibility to what you've done earlier, but there's some new capabilities and new approaches to building applications. One thing that's new that's part of this release is LangChain expression language, LCL, and this is really more of a declarative way for being able to build and compose our chains together. We're going to be seeing some of that as we go through the demo. So this is a new capability that you definitely want to read up on. Again, I'll be providing the links for you to get right to this if you want to read more about this LangChain expression language. So as I mentioned, it is a new release and there's a lot to it. There are a number of different components. So there's LangSmith, which is observability, meaning you can do more monitoring, kind of observing what's going on within your integrations. You've got obviously a deployment piece, so you can serve these up as services. You've got actually the core components, which is where we're spending tonight looking at LangChain community, which is all the integrations, and you've got LangChain core, which is kind of their more generic capabilities that they provide. And so we're going to be installing these libraries and walking through that. So LangChain core contains the main abstractions for the library. LangChain community, as I mentioned, is all of the third-party integrations like Chroma, FAS, and others. And then obviously you have some third-party integrations that actually have their own package, and that's actually the case with OpenAI. They actually have their own package, so we're going to be using the OpenAI package specifically tonight as well. So here I am in my Juniper notebook, and if you can do this locally on Juniper notebook, or you can use the Colab from Google. It works just as well for what we're trying to do. What we're going to do is we're going to go ahead and get started, and the first thing we have to do is we need to set up our connection to the LangChain libraries and install those, and we also need to install support for OpenAI. As I mentioned, there's a number of different libraries, and in this case, OpenAI actually has its own library. In some cases, some of the integrations, most of the integrations are going to be in the community library, but in our case, since OpenAI does have its own, so we're going to use that one instead. So we're going to go ahead and pip install those. Well, I actually already have them installed, but you'll go ahead and install those, and that'll give us what we need. Once we have that, we need to create our connection to OpenAI. Now, there's a couple steps for doing this. One is we need to create an environment variable, and we need to put in OpenAI API key into the environment. And there's a couple different other ways you can do it. You can actually provide it as a parameter to the functions for OpenAI, but to make it simple, just create an environment variable and put your API key. You're going to get your API key over at OpenAI. So again, if you don't have an account, you're definitely going to need an account to do that. And once you log in, you will go to the API keys page and generate a new key. And once you have this, go ahead and copy that. And don't worry, I'm going to go ahead and delete mine once I publish this video. But you're going to need that API key because that's what's going to get you access to the library. The reason you do this, obviously, also is you're paying for this. So this is one of the advantages of using something like LangChain is even though we can use OpenAI for something like this, we can obviously swap out and do another model that's open source or what have you. So, but for our purposes, we're going to use the OpenAI. They work really well, and to be honest, it's really not that expensive. And what we're doing tonight won't cost more than maybe a couple pennies. It's very inexpensive. We're going to be using a very inexpensive model for this. But just keep that in mind. You want to definitely make sure you protect your API key. Okay, so I'm going to go ahead and paste my API key in here, and go ahead and install that into the OS. So we'll have that variable there. Also mention that the way I decided to do this is I'm going to paste a few things. I might type a few things to keep the kind of flow and have it go a little quicker and not have to have you guys watch me struggle with typing, I might be pasting some things in, and I might be actually typing other things in just to keep the flow going. All right, so what we're going to do here is we need to import a new library here, the Chat OpenAI library from the OpenAI package, and then we're going to create a Chat OpenAI object, and we're going to use that. This is our connection back to OpenAI. So anytime we want to make a call to the OpenAI libraries, we're going to be using this object. All right. Again, since I already have the API key here, I don't have to specify that, but this is where you could specify things like the model you want to use, the API key, other parameters that you want to use to help kind of streamline or configure your connection, but we're going to keep it somewhat simple tonight. All right, so that gives us our connection to OpenAI. So now we're ready to actually invoke that and ask it a question. So let's go ahead and do LLM. Invoke is the function we're going to use. And we're going to ask it a question. What is REST? All right, and hit enter on that. Let that run. And there you go. So we have now successfully integrated LangChain back to OpenAI. So it's really not that hard to do to get started. All right, and we got a good message. This is obviously something that was generated by the large language model. So this is equivalent to asking a question in like ChatGPT, just asking any kind of question. Now we want to go a little bit further with this, is that we want to leverage some of the other things. Like for example, when you ask questions and you have prompts, you typically want to give it more context. You also want to have the history. That's the power of using something like ChatGPT, is it understands the conversational history. All right, so we're going to create a very simple LLM chain and ask it simple questions. All right, so let's go ahead and continue on. So in order to do this, we're going to have to create a prompt, and we're going to use that prompt to help fill out the context of the question that we're going to ask, as well as history and that you want to have, and obviously our question. All right, so we're going to import from the core prompts. We're going to import the chat prompt template. All right, and we're going to give it a couple messages. So this is where you provide the context and the history for the conversation. Or instructions. So I'm going to give it an instruction, and the first instruction is going to be a system instruction, basically giving it some context that you are a world-class technical documentation writer. So hopefully that'll help clean this up and make this a little bit better. It's not bad here, but we'll see some more context, I believe, once we run this a second time. And then you have your user message. So these would be equivalent to a user entering something in on a display. So in order to make these prompts so we can use them over and over again, we use variables. So we're going to create a variable for the user message. We're not actually going to put the user message directly in here. That's going to come later when we invoke it. All right, so the message that we want the question to be answered, that's going to be provided during the invocation of the chain. So here we're just providing the variable, basically saying where you see the word input, I want you to replace it with the actual question. And you can put these variables in multiple locations, right? So this is kind of how you kind of bring together your information along with the instructions and create custom instructions. All right, so this is a variable called input, and when you create variables, you just have to use curly braces to denote that they're a variable. All right, so that's going to be our variable, and we're going to use that later on when we invoke the chain. Let's go ahead and run that. All right, now we're ready to create the chain and invoke it. So now that we have that prompt, we're going to go ahead and create a chain object, or a chain variable, I should say. And we're going to give it the prompt that we just created. And here's where we're going to use the LangChain expression language. So we're going to be using a pipe symbol to combine the prompt we just added or created and our large language model. We're going to combine these together to create a chain. And that will connect that prompt to our large language model that we created above. Now that we have our chain, we're able to invoke it the same way we did earlier. And we're going to ask it our question. And the way you have to ask the questions is you're going to give it the variable name or variables. In our case, our variable is input. And we're going to give it the question. How can, well, that's the same question. What is REST? Okay, and we'll go ahead and invoke it. And there you go. So we got back our message, and we got, similar to what we had before. Maybe we have a little more context. Maybe it's a little better because we were able to provide not only the question like we did up here, but also the instructions to make your world-class documentation writer. For example, we could ask it another question or put some more statements in here. Respond in French. And let's see if that works. We'll run that prompt, recreate the chain, and we'll see if it comes back in French. There you go. So we have French. So it was able to translate that into French for us just by providing that additional instruction. So this is working correctly. And there is a very simple chain. Now, where it gets powerful is that we can go further with these chains. For example, it's nice we got the AI message back and we have to reach in there and grab the content out of there. We can actually format, we can tell LangChain how we want our output to be formatted. So if the output is coming back as, for example, JSON, which is necessary when you're doing kind of any kind of integration, right? We always want to get back JSON kind of structures. So we want to make sure that it always comes back correctly. There's actually a way to say, I want you to always format this as JSON. So it will do that for us if the content is JSON in the first place. And because a lot of times these models will return other things besides what we ask. So we have to clean that up, right? We only want the raw JSON. We can do the same thing with strings. So I'm going to kind of keep it simple. We're going to do it with a string just to show you how this would work. So what I'm going to do now is I'm going to go ahead and add on to our chain, and I'm going to add what is called an output parser. And we're going to use a really simple output parser that's going to convert our output that we just got and just turn it into string, an actual string. So we're going to use something called a string output parser. All right, and so we're going to say output parser equal string output parser. All right, and let's go ahead and create that. Now that we have that created, let's go ahead and go back, and I'm just actually going to copy this from up here, and we're going to recreate a chain, brand new chain here, but we're also now going to pipe it into a string or output parser, I should say, output parser. All right, now we have a chain. And let me make sure I create this variable correctly, correct names. There we go. Now I have a chain that has our prompt chained to our large language model, and it's also chained to our output parser. So if I went and kind of copied this again from up here and re-asked the question again, you'll see, assuming everything works correctly, I don't have any errors, that I get back just the text, right? So I don't have all this other details around it. I don't have those other objects. So just by parsing it through there. So what we've shown here is this is a really simple large language model chain. Okay, so this is just being able to have a conversational chain directly back to a OpenAI or whatever other vendor you want to provide and use. So now we're going to create a retrieval chain. And just to kind of set the stage, I've done a couple of videos on RAG, retrieval augmented generation, and I'm not going to spend a heck of a lot of time on it, but I do want to show you the problem just so you kind of see what we're talking about. So if I ask the question, what is LangServe? So one of the new services that has been added to LangChain was something called LangServe. So it's a way to deploy LangChain applications and make them runnable. And there's a lot of detail here. I'll provide the link for this one as well. So this is in the blog. But this is what LangServe is. It's fairly new. Okay, so it's a brand new offering. So if I were to run a question, what is LangServe? And just to see what it comes back with, I'm just really curious here what I'll see. Powerful language translation and localization service. Well, that's not the LangServe that I'm talking about. This is something else that may be out there, but it's not the one that I'm interested in. And it may just be confused. It could be an hallucination of the model itself. I don't know. I've never really heard of this. But the point is that there are times where we want to ask questions, or we want to ask information that may not be the model may not know of. It might be on private information. So how do we do that? And the way you do that is by retrieval. We're talking about retrieving. That's where RAG comes from, retrieval augmented generation. We're going to retrieve some data of ours. We're going to apply some context to the actual question we're going to ask. We're going to send that all to the large language model, so the large language model can then use that in order to formulate its response. So we're going to set up what is called a retrieval chain in order to do that. So the way we're going to do that is we're going to actually ingest this whole blog post. We're going to take all of this data and we're going to pull it into what is called a vector store. And we're then going to retrieve portions of the document and kind of break it down and parse it and do some things so that we can leverage the data here as efficiently as possible back to the large language model. So first thing we have to do is we have to then pull this data into our environment. All right, in order to do that, we're going to have to install a couple libraries. We're going to be using a library that will allow us to pull the text out of a web page. And you're probably familiar with it. It's called Beautiful Soup 4. And we'll go ahead and install that. And then once we have that, we're also going to install one more library. And that one is also going to be used as our vector store. For lack of a better word, it's more or less a database that's going to store the documents in a way that can be retrieved and sent to the large language model. And we're going to be using something called FAST, which is an open source one. There are other ones out there, Pinecone, Chroma. There's other ones out there, but this one's a pretty easy one to use. So we're going to be using this as essentially our little database to store our document text in a way that can be retrieved later. So what I want to do is I want to go ahead and copy this URL for this blog post. I'm going to copy that to the clipboard, and then I'm going to paste that in and use another part of LangChain that is called document loaders. All right, and we're going to kind of show you how that works here shortly. Here we go. All right, so we're going to paste in this just to keep down the typing. Excuse me. So we're going to, from the community, we are going to load in some document loaders, and we're going to use a web-based loader that's going to load the web page. Behind the scenes, it uses Beautiful Soup 4 to scrape the web page. We're then going to load that page into another document, and we're going to then grab the documents out. So if I run this, it's going to scrape the page, pull all the text off of it, and store it in kind of a text file or text object. So if I typed in docs here, you'd see that we should get all of the text for a document. So this is all just a straight text for that one blog post. All right, and I'm just going to clean it up. It's there. I just wanted to clean it up so it gets out of the way. Now, in order to use this in our large language model in the retrieval, we need to kind of create what is called an embedding. And if you think of an embedding, it's really just kind of a way to embed the documents in such a way that they can be recognized and retrieved within the OpenAI world. Okay, so they're just a way of being able to embed documents so that we can do searches against them in a way that OpenAI needs it to be. So we're going to be using from the OpenAI module, we're going to be using this class here, OpenAI embeddings, and we're going to go ahead and actually create an embedding here object, and we're going to call it OpenAI embeddings. All right. So that's a special model for embedding documents that we're going to be retrieving from our local document store. All right, now that we have that, what we have to do is we have to take that document that we just saw. So all that text from that web page that's here in that docs object, or variable I should say, and we then have to split it up into chunks because you can't send an entire document to the large language model. There are limitations to how big a document can be, and you don't want to do that anyway because it's also more expensive if you send a lot of data. So what we're going to do is we're going to split that document into chunks, into small pieces, and it's also going to do some other manipulation to it so that we can get the context when we need to. We're going to split it, and then we're going to take those split chunks and we're going to put them into a local vector store that we'll use for retrieval. So let me go ahead and show you what the split documents looks like. So if I just kind of run this, you should see that this variable, it's the same data that we saw in documents, except it's just been split into pieces. So there's a part of it there. There's one document. Here's another one. And they're just short chunks of the page into smaller pieces. So we have to do this. We have to split this, and we have to do some manipulation to overlap it. That's what the text splitter does. It splits it, and it also kind of recreates it in some of the characters actually overlap. The whole idea here is that we want to search our document store and pull out just the chunks that are relevant to the question we're asking. We don't need the entire page. We just need the chunks that are relevant. So that's what we do here is we're going to split that up into chunks. Now that we have those chunks, we're then going to take them and we're going to put them into our vector store. And you can just think of that as just a local database. It's a special database, and the entire purpose of it is to take our split documents, the information about how it needs to be embedded for OpenAI's purposes, and it's going to put them into kind of a local store database, if you will. We call it a vector store. All right, and then what we can do from that is we can then create a retrieval out of that, a retrieval chain to pull the pieces out of that document or that database. All right, so if we want to do this RAG or retrieval augmented generation, we need to create a prompt and a structure that takes our question, it takes any relevant documents that it can find from our vector store, package them all up, and send that all to the large language model. And that is the purpose of what is called a retrieval chain. So we're going to be using what is called a stuff documents chain. Essentially, we're going to stuff all the relevant documents into our prompt, and then we're going to send all that to the large language model. And so we're going to create a template, and the template's going to have the information so that the model knows what to do. So we're going to tell it, answer the following question based only on the provided context. And then here's a variable that's going to store that context. What is that context? It's the relevant documents from our local vector store. Okay, so we're going to search for similarities of the question we're asking locally. We're going to find the chunks that match the question we're asking. We're going to take those chunks, put them into the context, into the question, into the prompt itself, or the conversation, if you will. And then we're also going to put our eventual question there too, and we're going to send that all to the large language model. All right. So we're going to create a prompt out of that, and then we're going to create a document chain that's going to stuff all that together. That's what this is doing. It's creating what is called a stuff documents chain, passing the large language model and our prompt, and go ahead and create that chain. All right, now we've got the chain. Let's go ahead and work on the next piece, which is to create the retrieval chain. Okay, so we have our document chain. Now we need to create the retrieval chain that is going to pull both of them together. All right, so now we have the retrieval chain itself, and we're going to create a retriever that's going to go against our vector store that allows us to pull the documents out. And then the retrieval chain is going to take that retriever and the document chain from here, pull them all together, and create a single chain that has both pieces. So it's going to essentially fill all this together so that we can actually send an actual response to the large language model. All right. So now we're going to invoke that chain. All right, retrieval chain invoke. We're going to pass in our question. And actually the question I'm going to ask it is going to be the same question I asked before. And it's going to be this question here: what is lang serve? All right, and you can kind of see we didn't really get the answer we were expecting here. We got something else. Now that we're asking it against the data that we have stored locally and telling the model to only use that data, then we should get a better response. Let's check it out and see. All right, and let's go ahead and do response. And we'll reach in and grab the answer. And there you go. LangServe is a Python package that allows users to deploy any LangChain agent runnable. It's designed to make it easier to go from prototype to production and create production-ready API. So there we go. We got real context. Not very verbose. It's kind of short, but that's okay. It does prove that now when we ask these questions, we're getting it based on context of something we've provided. So that is what is referred to as a retrieval chain. Okay, so going back through the QuickStart and kind of seeing where we're at, we've basically gone through this retrieval chain portion and kind of walked you through how this works. Slightly different than what they have here, but it's pretty close. The last thing we're going to talk about is a conversational retrieval chain. And so the chain we created so far can ask a single question. It doesn't have any context. We want to be able to provide the conversation, right? Similar to what you would do within a ChatGPT style application where it remembers what you asked before. And we want to be able to provide that retrieval along with the conversational history together. So that is referred to as a conversational retrieval chain. And that's what we're going to create now. All right, so let's go ahead and change it up here. And let's go ahead and put in what we have to do for this. I'm actually going to put a little breakpoint here. And say conversational. All right, just so we can kind of see that this is the new thing. All right, so in order to create that conversational retrieval chain that remembers the history and the questions, we need to use another class, which is called a create history aware retriever. So it's going to remember the history. And then we're also going to use a special messages placeholder class. And that's going to be used to handle the history as well, and also handle whenever there isn't any history. All right, so we're going to use a chat prompt template just like we did before. And we're going to put a placeholder for chat history. And we're going to use that messages placeholder that I just imported above here. What this is going to do is it's going to put in place in the conversation any chat history that there is. If there isn't any chat history, it's going to be smart enough to know not to include anything there. But if we do provide any kind of chat history, any previous question may have been asked, that's where they're going to go. They're going to go in the conversation at the top. All right. Our input is going to be the same. We're going to put a variable in there for what we're asking, and then we're also telling it some additional instructions here to give the above conversation generate a search query to look up in order the information to get relevant to the conversation. Okay, so we're going to make sure that it knows that it needs to look up the correct information based on the prompt there. All right, let's go ahead and once we have that, let's go ahead and create our retriever chain. And we're going to do that this way. I'm going to go ahead and come down here. And I'm going to say retriever. And that's going to be create history retriever, and we're going to pass a few things: the LLM, large language model, our retriever, same one we did earlier, and then we're going to pass in our prompt. Right, so the retriever is the thing that's going to be talking to our vector store, and the prompt is the one we just created, and then this is going to hook back to the large language model. All right, now that I have that, we can go ahead and continue on with the next step, and that is we need to create. Well, actually, we're just going to invoke that chain just to kind of see it work and see if we can get the documents out. So we're going to say, is there anything new about LangChain 0.1.0? Actually, and we're going to do this one, is there anything new about, and we're going to do it differently because I was doing langserve. Anything new about langserve? Because remember, the documents that I stored were from that blog post about langserve. So that's all it really knows. So we'll say yes, and then we're going to ask it to tell me more about it. Okay, so here's the important thing that's worth noting, right? Here's the history. So I provided a little bit of chat history, and it's really supposed to be simulating a simple question about that was historic, like something we had asked before. That's what's going on here. We're asking it, is there anything new about langserve? And the AI message came back with yes. And then I am including that history in my retriever, but I'm also asking it to tell me more about it. So when you look at this, if it didn't know the context of what I had previously asked, then it wouldn't know anything about what I was saying here, tell me more about it. But since I do have the history there, it knew, oh, okay, I had already asked about langserve, tell me more about it. So it's clearly working off of the documents correctly. Now what this did is this just reached into that local vector store and pulled out just the relevant chunks that match the question. Okay, so remember there's potentially lots of documents chunks in these vector stores. We're getting back a subset of those documents, okay, and just the ones that are relevant for that purpose. So, and what we're going to do is now we're going to take these relevant chunks of documents that we retrieved. We're then going to go and ask the large language model about, we're going to take that information and we're going to pass all that to the large language model. All right, so that's what we're going to do here. Let me just paste this in here and walk you through this. So we're going to create the retrieval chain just like we did before. All right, here is our prompt template. That's the same. And again, we're asking the question based on the below context, just like we had from before. We are passing in the chat history and the user input, right? Just like before. And we're creating a document chain, and just like we did. And then we're creating what's called a conversational retrieval chain. And that is going to take in the retriever chain and the document chain. So it's going to take what we learned above. It's going to take that, and then it's also going to pass in my question along with that document and send all that to the large language model. So if I do this now, all right, and I don't have any chat history, and I'll say what is langserve. And hit run on this. And let's go ahead and output the response. And there's our document pages, and there is the title, and there down here is our answer. Okay, so there is and you can kind of see from this response, we have everything. We've got the input of the question. We've got our document chunks. That is the context, is our document chunks that we sent up, that we pulled out of our local vector store. Then we passed all that to the large language model, and it came back with our answer. So we now have the ability to not only retrieve documents locally, but we can also have a conversational aspect to it. And there you have it. That is how you set up a conversational retrieval chain using LangChain 0.1.0. Hope you found this useful, and if so, please like and subscribe. And if you like videos like this, please come back. And also, if you have suggestions of other videos you'd like to see, please provide them in the comments. Thanks so much for watching.